So, Naina Varsha, Amruta, where is your friend Lahari? So,
Uh, I don't know. Should I text her?
of course, as a friend, you should
Okay.
text her. See,
Okay.
she heard what we are talking. She came. You see, she's
Yeah.
here. As a friend, you should call. We studied in small schools. If you don't go to school, teacher will send the friends. They will, they will bring us to class.
Yes.
Yeah, welcome, Lahari. Hitesh, welcome. So you're entering into a very good module, guys. You're doing ETL. ETL fees for extract, transform, and load. You do batch. You do streaming. So this is what you'll be answering most of your interview questions, most of your certification. Lahari, you attended many interviews. Even I was interviewing a lot of people. You were there. Uh,
Yes, Shani.
you might have already got a pattern, correct? You,
Yeah.
you talk about ETLs. Even a lot of people even don't even talk streaming. But good, you are learning. So that's all, guy. Most of the time, as a data engineer, you do ETLs. So batch ETLs, streaming ATL. So I'm pretty sure you started spending some time on the streaming. It takes some time to wrap your head, Naina, but slowly spend your time. Think about it. Start writing a couple of lines of code. Okay, if I read Kafka, how I read it. So if I read a data on the store, how I read. It's just a matter of syntax change. That's it. So here you see read stream, there you see just a spark.read. So that makes a big difference. So once the stream starts, so it's a continuous. Whereas in the batch, you just read once. You just read once. That's it. You have to repeat as a with a schedules with schedule. Run it hourly, run it uh, 24 hours repeated. You need to schedule it. Whereas, Hitesh, can you put on mute? Vamsi, welcome. So the streaming is a continuous, kind of continuous schedule. So I think Vamsi is expert now. He is reading Kafka and what is that, Flink, a lot of other things, But at least now we agreed. Kafka is okay, but let's focus on Databricks. How are you,
Yeah,
Vamsi?
yeah. You convinced me, to abandon Flink. Yeah, I'm convinced actually. I mean, it makes sense. If we are in a group, let's go with the group. That way, we'll travel further. Yeah,
Correct. In fact, I'm very inspired by your curiosity, Vamsi. But again, time is limited. We have family, kids, and a lot of things to do. So let's double down what is working, what has a market. So that we all can travel more or less together, helping each other. So there are a lot of opening, guys. 2025 will be very, very good for Databricks. Of course, till now it's been good. I've been in this field last 6 years, and then 2 years General Spark. It's been treating no issues. It's been treating very well. So I don't see any issue at least next 3 to 4 years. But only thing is double down, double down. See, if initially it appears, but you just have to repeat. That's where people start seeing. You should be very comfortable with batch. You'll be very comfortable with streaming. Get into it. Start coding it. Then see. Ultimately, you do ETL, extract and transform. That is the main thing. After that, you load. You have to load, guys. Everyone. Simple. A load. When you're loading, you can load into 100 different ways. You can write it to Hadoop. You can write it to cloud storage because you may be in AWS, you may be in Azure, you may be writing to ADLS directly. or you say you are storing to Delta format. So they're all, even though it's a Delta format or general Parquet, most of the time you'll be writing these two, Parquet or Delta format. So Delta format is a storage format created by Databricks, and it is a open source. There is another format called iceberg format. Iceberg format. We'll discuss in the class. So that is also another way of writing it. So these three you will encounter: Parquet format, or Delta format, or iceberg format. Interestingly, Databricks also purchased a company behind iceberg format. Iceberg is an open source Apache Iceberg. So like a Delta format. In fact, Databricks made a concept called iceberg and Delta are compatible with a concept called uniform. So there is an abstraction layer called uniform. It means if you are using that uniform, you can either write it to Delta or write it to Parquet. Parquet anyway you can write it to Delta or iceberg. So focus on Delta. The idea of Delta storage is the very fact of storing data. Vamsi, please observe. You are writing onto a blob storage. When I say blob storage, either a distributed Hadoop storage or ADLS or S3, a cloud storage. They are plain storage for you. It's available to you. So when you are writing it, think of a Parquet files. So what you're doing is you're writing it, you can append it, you can append it, you can append it, or you can refresh it. You can completely overwrite it. Those are easy way of writing it. But what happens? What happens? Suppose you want to do a merges. See, what is a merge? It's a kind of upset, right? Upset. You insert if there is if the key doesn't match, or update if the key matches. It means in any table, already some data is there. Naina, please observe this. Suppose you have a table, assume even Parquet table. Say you have data is there already. When you are writing it, append means you just append to. You have 100 rows, you are appending another 100 rows or 200 rows. So if you are simply appending, you may have duplicates. You may have duplicate keys. So whereas if you take any RDBMS, like Oracle or on-prem RDBMS, what they do is they don't just append. So if there is already a row, you will update the row. You will update the row. If there is no row, you will insert the row. That's what it's called. It's called upset. It's called upset. So if you have to do an upset, see the complexity. The complexity is, these tables, you need to find what is the key first of all. Because first you need to match whether it exists or not. It means this table should have indexes. Indexes need to be built. Okay. So you need to build the indexes. Next is you need to match. Suppose 10 rows matched. 10 rows needs to be updated. The remaining rows should be inserted. So, so either the transaction, you have a 1,000 rows, 100 matched, 100 insert, remaining 900, you need to, rather, first 100 update, remaining 900 insert. If there is some issue on writing it, should completely roll back the whole set of transactions. So that's why they need to follow the concept of ACID transactions. ACID means atomicity, consistency, isolation, and durability. Atomicity means whatever the transactions you are doing, you should either do it or roll back, right? Consistency. So there should not be any confusion out there. Your transaction should be when it is updated, it should be consistent. It means when you write 100 rows, you should be able to write those read those 100 rows. Isolation. It means if multiple this job is writing, this job is writing to the same table. So if there is a conflict, it should resolve the conflicts. So as much as possible, they should work isolatedly. If there is a conflict, your system should be in a position to wait a few seconds until it is done. It has to wait. So isolation, durability. After you write it and the jobs are done, the data should stay there. It should be durable. It should be durable. So do some reading on it. So this type of questions also people ask. So all those Anush, all those acid properties need to be bought into a storage if it has to meet your real what you called the needs of the upset. So prior to Delta, this Delta is created by Databricks. Prior to Delta, only the storage can only do the appends, inserts, just appends, just refresh only. So only limited use cases can be addressed by these blob storages, Vamsi. So these use cases have been growing now, especially if you see GDPR, CCPA, the security what do you call rules, right? Laws, right? California, what is that, Anush? What is CCPA? California CCP Protection Act. GDPR is a global data protection act, so regulation, something like that, European. So what does it mean, Vamsi, Anush, and everyone? Suppose you are a Nike customer. You should, if you ask Nike, hey, remove all my data from your systems. It means within 90 days, they should remove your data across all the systems. So removing data, deleting data in the OLTP systems is easy because you know the key, these rows need to be deleted. But in the OLAP systems, in the blob systems, if there are billions of rows of the different Nike's data, especially if they're tracking what you called Nike running app, heartbeat apps. So there will be a number of transactions. For one customer, there could be million transactions. So finding 100 customers and deleting those rows out of billions of rows is a big thing. It appears for you it's a delete statement. But those are exist in multiple files on the blob storage. So the deletion is a very painful thing. So that is where it has to have indexes and it has to identify those rows. And those rows exist in multiple files. It has to identify those files. Then it has to delete and create a new files of that. So it's a big exercise. Deleting is very, very difficult exercise in the blob storage. But anyway, long story short, the answer is the ACID storage supported by Delta Lake. So the Delta Lake, the way it maintains ACID storage or these capabilities, maintaining a separate log file, a transactional log file, which tracks everything. So say you have a table. What happened to the table? Did you insert the row? Did you update the rows? Did they append the rows? All the history, it is the metadata is stored in the delta log. So delta log is like like a notebook writing what happened. This class happened. This is recorded. This happened. This happened. This happened. Like that, there is a delta log. So Harun will walk you through. So this topic is very, very important for the interviews, even your own understanding. So especially when you are solving deep problems in the Databricks ecosystems, this is very, very helpful. And it's very interesting also, Anush. It's very interesting also. It's a simple log, but provides a powerful capability for the table. So this, because of the delta log, you have the superpowers almost, like you can even do a time travel. It means 10 days back, we updated this table. I think that update is wrong. So last 10 days, we've been updating. We have, as we are updating, every time you are updating, the table version is changing. Version 0, version 1, version 3, version 2, version 3, version 10, version 20. I want to go back to version 5, Anush. So you can roll back the table to version 10. So it means you have a table whose state is changing over a period of 10 days, 11 days. Then you realized after 10 days, the updates you done is wrong. You need a table state of the older version. You can roll back to that state, Anush. So you're not taking backups. Please note down here. Please note down here. Like Oracle, Oracle, they take daily backups. Daily backups. Suppose you want to roll back to 2 days, you will call your Oracle DBA and hey, can you roll back to our database? So here you don't need any backups. The the Delta storage with the Delta log capabilities, it rollbacks to a state. It's called time travel. Time travel. So those capabilities it brings, and even a lot of other things like the schema enforcement. So Delta Lake storage has a lot of features. So Harun will walk us through step by step. I want you to focus. I want you to practice. I want you to get ready for the certification and get ready for the interviews for 2025, guys. Awesome. Harun has taught this multiple times and gives a amazing session. Even I get inspired. Harun, any comments? You're on mute. You want
Yeah, thank you, Srini. Yeah,
anything as intro I'm missing?
No, you're good. It's awesome. So it's basically very interesting, very exciting to look at the Delta transactions, basically how it handles the time travel concept and the ACID transactions, how it complies with GDPR and CCP, how it addresses those use cases. Yeah, it's all very interesting and exciting to.
Wonderful. Before that, anyone, any question? It's just a basic intro. Naina, Anush, you just got the hang of it, what we are talking about? You're going to learn the Delta storage, how it stores, how it stores in the table, how the Delta log, you keep track of all that log, what happened to the table, how you roll back, all those details we are going to learn in this module. Any questions, Hitesh?
Srini, I have one question. So these files, Parquet files and all that, or the Delta tables, are they distributed across the nodes, or are they distributed in nature across different physical servers?
Okay, let's think first is, once they are in the storage, they are in the blob storage, right? Like S3 or ADLS.
Yeah.
So Blob storage is then that blob storage, they split these files to a managed like 263 MB, like that, the pieces. They're distributed as far as the size. But as far as the machines, they are distributed only when you are doing a computation cluster. Say you have a cluster, Cluster is you're doing a processing. At the time, it reads from the table and for a computation, it distributes. But once your transactions, transformations are done, once you storage, it is there on ADLS. It is there on the S3. So now you don't talk anything about this mission. This mission will even die because you finished the process, right, Vamsi?
Yeah. Okay.
Now the storage is there. The Delta storage is there on the S3 or ADLS. So that storage, we just call it as blob storage. We don't call it as a distributed storage. Only thing is, those files are not one file. Those files are splittable. That's it.
Okay. Yeah. Okay.
Makes sense?
Yeah, it makes sense. Okay. That's interesting. I guess.
Yeah.
But is it typically stored on one physical machine, even at large organizations?
That is abstraction. Actually, they won't tell. Actually.
Okay.
They won't because it's not a compute. Since they separate the storage and compute, they won't say how they store. Sometimes it's in fact, a layer. They show sometimes they even store hash storage. It's a very funny way of how they do it. Okay.
Okay, thank you.
Go ahead. Good question though. Thank you. Bye. Arun, thank you.
Yeah, thanks, Srini. All right. Yeah, welcome team. So I think we are progressing well with all the topics that we have been covering as part of our training. So we have done all the processing stuff, like, we have done the batch processing, we have done the stream processing, we have looked at the JSON, we have looked at the streaming from Azure event hubs, streaming, how to process, right, and all the JSON files, etc. So based on that, now we are doing all the processing, and then we are seeing the data is being written, and then we are reading back, we are doing transformations and all of that. And then we have also looked at how the actual processing happens last week, right? So distributed processing and the joint strategies and caching. So when you do the processing, distributed processing, where you have multiple machines or nodes, that which work on a specific part of your data frame or part of the data, the transformations that they apply and how data shuffle happens and all of that. And then we are writing. So, but when you actually write, that's where we are going to double click now. See what happens when you write, or how do you read? How does Databricks or Delta Lake brings back the data? So when you're writing, you say the format as Delta, right? So when you say format as Delta, what happens? How is its storage structured? Basically, we all know where the data is stored, right? So where is the data stored? Underlying data. When you're writing any data from the Databricks, where is it stored?
It's stored in cloud.
Yeah, cloud, but where on the cloud?
It's where S3 or ADLS.
Right. Yeah. So it goes to the provider, right? So the storage provider, which is what you choose, whether you want Azure or you want AWS or you want GCP, which you want to put your Databricks on. So that's the storage. And the compute. Compute is what you create. Basically, Databricks allows you to create, but internally it uses the physical machines or provided on the cloud by any of these providers, hyperscalers, right? Now, you write it on let's say it goes to Azure ADLS or it goes to S3, the files storage. But then to manage it, when you write, the Databricks will create a wrapper around it for Delta transactions, where when you say storage as store as Delta, what is the file format that is stored? The actual file format that it stores? Parquet, yes. So the end result or the lowest level, the actual data is stored in a Parquet file format, .parquet, which is machine readable. And then on top of that, it builds this a wrapper or layer called Delta, right? So when you call the Delta format. So then this Delta layer is what manages those Parquet files and lets you read or write based on the transaction log it creates every time you do some transactions on the data. Okay. So what it does is it has a metadata and then it has the actual data. So the actual data is your Parquet files, right? So it creates a folder and then it puts all your data in that folder for any specific table. That is your data.parquet files. Then there is a metadata that is created. So metadata is basically two types. One is the JSON file that we talked about. We looked at how the JSON file looks like. So there is a JSON file created for every transaction that talks about what is the actual changes that is done to the data. Have you inserted some data? Have you deleted some data? Have you updated some data? And as a result of doing that transaction, what is the impact on the existing files? Suppose I have 20 files, of data, because see, all your data is not going to be just in one file, right? So there will be multiple files within that folder for the table. Now I have million rows, as Srini has talked about, and then those files are in 100 files. Those data is split into 100 files in the folder. Now I have to delete a record for a customer. Just assume that, okay, that customer is in, one file or two files. So when you do the transaction, what it does is it will remove, or actually it will mark those files as deleted and then create new files with the data, which is not having the data of those customers that you have deleted. And it will write this particular transaction in the JSON file saying that, hey, this transaction was done, delete. As part of this, now the files are these files. See these 98 files that are marked active, and these two files that are not relevant. Somehow it manages all that transaction. So next time when you say, give me all the data from this table, it knows that it shouldn't give you data from those two files because they are deleted or marked as delete, right? And then after some time, it will physically delete those files after not used. So maybe 7 days or so, when your time travel is expired, right? Or you do a vacuum, and then it will automatically delete those files physically. But until then, they will be there. But still, the transaction log will tell you which files to access. First thing. Second thing is when you're querying for some data and it has 100 files. So it shouldn't go and scan all the 100 files to get your data, right? So to improve the efficiency of querying, it also maintains some statistics. And those statistics are also written in the transaction log for all the data, metadata. So that metadata is written in the JSON file. So every time you go and do something on the file, it first goes and checks the JSON file or the metadata file. And then it will derive what it has to do based on the metadata that it has on the in the JSON file. Okay. So that is how the delta transaction is. So let me share my screen and then we will get started looking at the transactions, actual transactions. Okay, so this was I was talking about just on visual representation. There is, you create a table initially. So every time you do some transaction on the table, you get a new version created. Basically, if you do any upsets or update or insert or delete, not read, and anytime you write or do any transactions on the table, there is a new version of the table that is created. So which means it keeps creating the snapshots. Okay, so every transaction that is committed, it creates a new version. Okay, that is what will help you in doing a time travel. So when you keep on creating new versions, you can always go back to an old version and see how the data looks like. You can just go and look at it, in the history, basically in the time travel, to see show me how the table looks like in the past on this day by timestamp or by version, as of version 0 or as of version 5. Show me how the data looks like. Then you can also overwrite and say, hey, I want to go back and make the current state as it was 5 days ago, or we version 5. I can take that and make it current, just overwrite as a new version. So that will become your latest version. So then it's almost like you have rolled back to 5 days of the data. So that's you keep creating versions every time you do a transaction on the table. You write the data, and then it creates a metadata, which is your JSON file, and then it creates the data files, the actual data in the Parquet format. Okay, so if you add 1, so that's a Parquet file, and this is the JSON in the Delta log you call. So it gives you add, what is the path where it has added this, what is the size modification, data change, and then statistics. What are the records? What is the minimum value, maximum value, and all of that stuff? It creates a transaction in the Delta log. So you don't have to go through each and every line of this and understand what it does, but as a whole, we want to explore and understand how a Delta log, a transaction log, helps in making Delta Lake efficient, right, for asset transactions and addressing the use cases. That's what we have to understand. Okay, just like Spark internals, this is Delta Lake internals, you can call. So how we have seen how Spark works based on the DAG it creates, the stages, the tasks, the parallelism, the partitioning and repartitioning, data shuffle, and all of that. The same thing. This is the internals of Delta Lake, how a Delta format is internally managed when you do some transactions on the tables or on the files that process. So if you read the actual JSON file, you would have all of this. That's what we were looking at. So there is an add, which is a struct. All of this data, metadata will be there. There is a commit info, operation metrics, operation parameters. There's a lot of metadata that we will look at. But so you can actually go and read that same metadata file, the JSON file, and see what is there in the transaction log. You cannot read the Parquet file, but you can read the JSON file and see what is the metadata that it is storing. Okay. Any questions on this before we go into actual practical, take a file, do some transactions, look at Delta log, and then do some more transactions, do time travel, schema merge, right? And we can see how it manages all the delta log when you do all of these kind of transactions. Okay, any questions? No? Okay, we're good. Let's get started. Okay, so I have this notebook called diving into Delta Lake. Okay, so what I'm doing, I'm creating a loans delta table in the Delta DB. Let me see if we have this. If it is already created. Okay. Okay, maybe we don't have the Delta DB. So because it's a new, every time you drop the cluster, you lose the catalog and tables, right? So let's say I'm creating a new table, DB, create database, and use that database. And then we are setting some properties, optimize, write, and format check, and all of that. This is just this setup, okay? And let me see here. Do we have? Okay, so we have Delta DB created, right? Now what we are doing is we are creating a directory called loans parquet, and we are getting wget. This is a command to get a read data from this location, snappy.parquet. We are just downloading this and then putting it in the in this location, this file. Okay, so let's get this file. And then we will go and check if the file exists in that location. So this is just, we are setting up the data to do our transactions. Okay, so yeah, so there is loans.parquet. That file is there. This is the time, modification time, and this is the parquet file. So remember, this is just a parquet file, not a delta table yet. Okay, so what we are doing, we are reading this parquet file and adding two columns here, type and timestamp, and then we are writing back as loans underscore delta table with overwrite. Okay, so remember we were doing read CSV or read JSON. The same thing we are reading now, parquet file. The format is parquet that you are reading, that file. Doing some couple of some transformations, adding two more columns, and then writing as a delta table. Is this part clear, everyone? Any questions?
There's no difference.
Your voice is breaking, Anush.
Can you hear me now?
A little better. But...
Is it better now?
No, still the same. It's muffled.
Can you hear me now?
No. Is it your microphone or your AirPods or?
Yeah, I'm using microphone. Yeah. Okay, I'll talk later. I'll ask you.
Yeah, go ahead. Let's see if we can try that.
So here now, irrespective of it being JSON or CSV or Parquet, it's all the same.
Yes, irrespective of CSV, JSON, Parquet, it's all, it's just a different file format that you are reading. Once you read it, it's all same. It's all the same data frame. Only how you read it, what type of file you are reading, you just have to specify that format and maybe some kind of options based on that format. Like for CSV, you can specify what is the separator. If it's not a comma, if it is like a pipe, how do you handle reading that file, pipe separated file, thing. If it is a JSON, then you can specify, is it a multi-line your file or single line? Different options based on the format that you can specify. But once you specify the format and load, it's all the same data frame. Okay. Yeah. So now we have created loans delta table here. We can go back and check. See, this is loans delta. Okay. So you got the schema here and you got the sample data here for the team. So let's look at, we can see history here. Okay. So you can see the history. This is the same location that we are using. So 811, it was originally created. 1123 is what we did. So these are old transactions that we did on 811, original one. We can actually delete the file and recreate it. But so let's say this is our baseline version that we did today. These are all the transactions that were already done on the location on that file. So now we have dropped and created a new table on that file location. Okay, so go back here, take that as a baseline. We will go through. So you can do Spark, SQL, data. What is the transformation? So what is the count and what are the columns and all of this here. So now we'll look at the Delta Lake transaction log. So what happened? So first we will go and say describe history. So it will here show you what is the version that was created. If you see the same history that we were seeing there, 0, 1, 2, 3, 4, and what timestamp it was done on of those tables, and operation parameters, job, which notebook was used to do that. So you can also get the notebook ID, what you used to do the transaction or the transactions on that file, cluster IDs, all this information. Okay. Now, Databricks runtime and all. So operation metrics, you can see here, number of files is 1. Output rows is 14,705. So these are the rows that were written. So if you see here, it will be the same count that you get from the table. Okay. And output, these are the number of bytes. That's the size. We'll come back here, how we get from this. This is just the transactions you do, minimum, maximum that we do here, funded amount. So if you look at the data here, we have loan ID, funded amount, paid amount, all of this. Okay. Now we are taking minimum and maximum of funded amount. So minimum is 1000, maximum is 40,000. So this, what we did here, describe history. Now we are going to check what is the format of loans delta. Formatted, the same thing. So you get here, what is the column name and all of that, catalog, location. Okay, so this is important. This is where your files are stored, the location, physical location on the machine, that path where your all the files that are stored whenever you do transactions. Now that you have inserted data frame and written to this table, so a folder is created with the same table name under that database, and then the data is written here. So provider is Delta, and you have some table properties transaction thing. So we are now going into the file path, loans underscore delta. See, there are two ways to view that. So one is we are going to look at the actual file storage, how the files are stored and where we get all the files and all of that. And the other is using the delta format. We say what is the statistics for the table itself. So what is the table? Where is the location for the table that it is stored? And then what is the statistics for minimum, maximum columns, all of that metadata for the table. So there are two ways to view the metadata. So here, if you see in this path, delta db.loans data. So this is the delta log. This is the actual delta log, that is a folder that is created. And these are the files, part files. This is the data. .parquet is all data. And this is the delta log folder where the transactions log is created. Right? Are you guys getting this? So we see here metadata, we said JSON, and we said data goes to Parquet. And there is a version that is created, correct? Guys, are you able to hear me? Hitesh,
Yes,
Raju,
Yes.
Anna, okay. So you understand what's happening? Any questions?
No questions, Harun. It's clear.
The only question is the metadata is also part of the same file, right? Or is the metadata stored in a different file?
Metadata is part of the same path, not files.
Oh, same path.
Loans delta. So each table's metadata is all managed within that. There's no central repository for doing the transaction log for that table. So each table's transaction log is local to that path.
Okay.
Loans delta, inside loans delta, you have something called delta log. In that folder, you will have the transactions. So if you go and look here, so in the loans delta, as I said, first there will be data files. Okay, 1, 2, 3, 4 files are here. And
Okay.
then we have delta log. And if you go inside the delta log, then you will see all of these JSON files. Okay.
No,
So,
but so looking the extension .parquet, you're saying anything with .parquet is a data file.
yes.
But if I want to know the metadata
Yes.
of that Parquet file, what is the extension of that file and where is it located?
Yeah. So the metadata is not specific to each Parquet file. Metadata is specific to the transactions that you do. So your one transaction can result in 5 Parquet files, 10 Parquet files, or 100 Parquet files.
Okay, that's understood.
Yeah. Now your metadata is under this folder, delta log.
Yeah, can you show?
Yeah.
Here, can we
Right.
see
Yeah.
one of the, and what is the extension of a metadata file?
That's what I'm showing here. We go here, delta log. These are all the metadata. It's, as I said, JSON and CRC. Okay.
JSON and CRC.
Yeah.
And so metadata, though, it's a very slow changing dimension, right? Why do it create so many of those? Let's say, see, what I'm struggling right now is metadata tells you the shape, the form of the data structure, and maybe some other things like who can access or, things like that, right? So let's say you invoke a transaction on a data file.
Mhm.
I'm thinking it doesn't result in a different metadata, or am I wrong?
It does.
Why should it?
So, yeah, so that's what I was saying, right? We will slowly come why all of this. We will get there. How all of these are used. So if we go back, we talked about each transaction will result in a new snapshot of your table. Correct?
That's understood, yes.
Now, how do you know which snapshot has what data? Let's talk about rollback. I want to go back last week and I want to restore all the data as of last week. Say last week, every day I'm creating a new version or only one time. Let's assume, okay? So each day I have a version. I want to go back last week, which was the current version. If it is 10, last week's version -7 is version 3. I want to delete all 7 days, or I just want to roll back to V3 and make that as my current table. Now, if I go to V3, I should get the current state of the, not current state, the state of the table as of version 3. On that day, how the table looked like, or what was the data present in that table, what were the columns that were present. Maybe I have dropped some columns later or added some new columns later. But at that point of time, what was the schema of the table? What is the data for that table? So how do I get?
Okay.
To
So you're
derive
saying,
the state of the table at any point, it uses that transaction logs. Okay. So here, if you see, you can see there is a 01.json, 02.json, 03.json, 04.json. So this is basically your version number. Now you connect back to your history. If you see here, what is your current state that it was showing? See the versions. Where is the versions? Yeah, history. If you go back, see version is 0, 1, 2, 3, 4. Right? So version 4 is what you have done today. Now, if you want to know what is in version 4, you go to version 4.json and then it will tell you what you did on that version of the table. Okay. So go here and see. We'll go there. Okay. Now I want you to understand. So this is
no, this is good. Yeah, thank you.
Metadata on the Delta log. Now it stores a CRC file and a JSON file. CRC is just some other internal thing that you uses, but we will focus more on JSON from the transaction perspective. 00 JSON is basically, let's say, your original version 0 when you actually created the table, okay, and added data. Now we have seen the current version is 04.json. You can actually go and read that JSON. That was what I was telling you. You can go back and say, let me just comment out all of these and we go step by step. Spark.read.json. See, now we are reading JSON file. Earlier we read Parquet file. Now the metadata is a JSON file. I'm just going and reading spark.read.json. And the path I am giving is this path. Where is the 00? Yeah, this path. Okay, take this path and just put it and we can run the JSON file. So whenever you read, it's again a delta log. Sorry, what am I saying? Data frame, basically. Okay. version 0.
Mhm. Hari, one question.
Yeah.
Is because this is does the Databricks or third party providers do they provide an application that allows you to graphically navigate all of these things, or
No, it's just a file
that's
system. It's a Databricks file system.
yeah, it's a file system only. No, I'm like
Yeah.
just interested if there's any third party tools that actually kind of give you a, just by visually navigate here and there and all that, or
Normally,
that's not
no,
there.
because see, this is the metadata of the table, right?
Mm.
Normally you don't give access to anyone. It's managed it should be managed by the system. If you go and delete some transaction file, your data is corrupted. You cannot reach to that data.
Okay.
Right? So access control. It's basically the once you remove the metadata, all your data is useless. It cannot read, it cannot
Sure.
give you anything, it cannot do anything. Right? So because it doesn't know what to do with the data. So it's highly secured and confidential, or a private. We are doing it here because I am the owner and I have access to the file system and all of that. All right.
Okay.
So this is just for understanding purpose. Normally in day-to-day life, you would never go to this unless you want to troubleshoot and check what happened in a particular version, right? So if you want to go there, that is how you would want to look at the data. But in general, normally you don't have to go here. This is just to understand how Databricks Delta works, basically. Okay. You can get all the commands from here, right? So you can still execute these commands, basically describe formatted, describe extended. It will give you all the path and the versions and all of that history, everything you can get from the table thing. Okay. So this is the path, loans delta log. Just give me 1 second. 2. Okay. Yeah. So this is the 4.json, right? So I'm going in here. I'm viewing 0.json original when it was created. Add. So what was done at that point of time is there is a what if the data was added, right? So data change true, modification time, and what is the path of the Parquet file that was added, statistics, number of records, minimum values, maximum values. See the metadata, right? What metadata it calculates? It also calculates statistics, size, and path to the file. What happened? And then insertion time, how much time it has taken, target size, and all of that. So this is for the 0 that we have done, but later we dropped the table, deleted everything. So we actually kind of removed the data from the table. These are the files that were still there at that location. Now what we did today latest, this is what we created 04, right? So let's say we just want to focus on 04 thing. I want to see 04. What happened in 04? This is the latest data. Now, if I look at it, see, add 14,705 rows. That is the count we have seen. In the statistics, so minimum value is for funded amount, it is 1,000. Maximum values for funded amount is 40,000. Okay. The same thing if you do here, remember we did select minimum and maximum. So minimum is 1,000, maximum is 40,000. So for this kind of queries, it doesn't even go to your data. It directly picks up from the transaction log and gives you the data. Okay. If you are doing any, simple max min kind of statistics that you want to see on any of the columns of the data, that is every time it's calculated and stored as part of your delta transaction log. So it will directly get it from here and give you. Okay. If you want paid amount, funded amount, and these are actually strings. So they don't have max min values for strings. So it's just an alphabetical order that it stores. Now, why is it useful is, again, if you have a range, each file has, let's say, different max min for each file, then it can directly go and check based on the where clause, which files it has to pick up. It will just compare, hey, my value, does it fall in this range? Then I only pick up this file to read the data. So it can skip the unwanted data files. So it doesn't even have to go and read those files. So that will improve the efficiency when reading. So that's why it calculates the statistics and it uses when you use the select queries. Okay. So this is the JSON file. Now we can do some transactions, not transactions. So we can execute some commands on this and view different types of metadata. You can also run just like a data frame, right? So you can also run the commands. Oh, let me run this. This is the delta log, and okay, I have to use delta log here. Okay. So you can also write your select statements and where clause on this data frame. So where you can say commit info is not null, add is not null. This will give you what is your commit info, what is your add. Whenever there is only add in the file, only that blocks you can see. It's basically how you want to view the data from the transaction log. Okay. Any questions on this when we go forward and start doing some transactions on this log? Anush, Naina, Hitesh, Manideep.
I'm good, Harry.
Okay. Everybody good?
Yeah, good.
Yeah, good.
Yeah, Haran.
Okay. So you're all clear, right? So how the transaction log is created, how it is managed. Yes. Basically, to recap, every time you create a table, there is a delta log folder that is created where all the metadata is stored as a JSON format for each transaction that you do to the table. which results in a write operation. It creates a new version, and then it creates a JSON file and a CRC file for that. Okay. And that JSON file, every time you read or do something to the table, first thing it does is go and read the JSON file, the transaction log for that table, and then it derive what it needs to do with the data files. Then it will go and read this related relevant data files and then does your operations based on what you need to do. Okay. Now, so this is, yeah, let's move forward and do some of the transactions on this table. So before going here, one question: what is the current version of the table that we are doing now? Anyone? What is the version of this table?
Is it a new one, or is it a? I'm not able to see.
We have seen this, right?
Yeah. Are we using the same one?
Yes. So
Current
whenever you do
four.
latest current, yeah, current is always the latest version that it picks up.
So 4 is the. I think it is 4. I didn't see.
Yeah. Version 4 is the current version. Okay. So even if you see in the history, it was shown. Formatted version. Should have somewhere.
Or probably down in the JSON files, it'll give the version.
Yeah, the latest one. But you can see here in the history anyways. So this is the version that we created at 11:23 today, timestamp. Okay. So that is the latest version. Now let's move forward and then talk about, so this is the standard, we keep revisiting this, the data that we processed, right? Batch, streaming, Spark, bronze, silver, gold transformations. And from here, you can either BI, ML, whoever can read this. Schema enforcement to protect data quality. Okay. So this is one use case. So we are going through what use cases the Delta Lake, the Delta format supports. Okay. How do you enforce the schema? Now we are saying new column struct field. We are adding a credit score to the existing table. New schema is you are taking the existing columns from loans data, spark.table.schema.fields. It will give you all the fields of the loans table, and it will give you the schema. From schema, you're taking the fields, plus you are adding this new column to the new schema. So basically, you're taking all the existing columns and plus adding a new column here and calling it a new schema. And I'm taking some data as a list, or you can say array. So this is my record for the columns, and this is another record for my columns. And remember, the last one is my credit rating that I am giving for these two records. I'm adding for this data new schema. So I'm creating a data frame. So basically, we have not done this earlier. You can also create a data frame with, the data that you provide here. Just initialize the data and then create a data frame here. Most of the time we are doing was to read from a CSV or read from JSON, read from Parquet, or read from a table. Those are the ways that we have been creating a data frame. Now I can generate some data here and then use that data to create a data frame here itself. So I have a schema, I have data, then I am creating a data frame with this data and this new schema. So I want to print the schema and display new data. So this is a, oh, what happened? Schema mismatch. When writing to the delta table. Create data frame. Oh, this is different one. This is different. Okay. Schema fields are here. Okay.
Varun, where is the column name in that when you're creating a new column?
Oh, 1 second. Credit score. Oh, there's already a credit score. Okay. Let me go back, recreate this. And then let's create this. I will make a new table. So can do this. Okay, no confusion. We created a table with just new table version 0. Okay, let's not go back to the old one. There's some confusion. The previous data is also there. We have to delete all that data. So I created a new file with the same. Oh, not this one. This is different. Okay, same data that is inserted. Oops. Okay. Okay, now you have only how many columns? 1, 2, 3, 4, 5, 6 columns here. Okay, the credit score is not there. See, you guys, can you see this? Can you observe?
Yes.
Okay, so the credit score column is not there. Earlier, we were trying to do existing loans delta. It already had credit score, and then we are trying to add again credit score. That's why it was throwing error. with this. So if you go here, this is the path, this is delta log. Now the path is actually created based on the table name. So even your file path will change. Okay, now you see there is only one 0.json because this is the only version we have for the table, the first version. So now the latest version, first version, origin, whatever is everything 0.json. Okay, so we can go here and check this. Start with 0.json, run this. Okay, the path is wrong, underscore new. Go this. Okay. So we have one, again, same, it's an add. This is the modification time, number of records 14,705, minimum, maximum, all are calculated. Statistics, everything is good. Okay. We can just do a select. If I just want to see commit info or I just want to see add data info, you can do that select on that. Now we come here. Okay, we're talking about the column name, right? See here, I am naming that new column as credit score, which is an integer type, and nullable is true. Okay, this is a new column. This is struct field. This is a field, new column, struct field. The schema is a struct type. Basically, it's a higher level, right? So struct type, in the struct type, you have all the struct fields. Each field is a column. Got it?
Yep.
Okay. So I am creating this new column, credit score, which is of integer type. And then I'm adding it to the existing columns. How do I get existing columns of the table? I will just say spark.table, zones delta, sorry, new. So this will give me my data frame. Dot schema will give me schema. And then dot fields will give me all the fields from that schema. So if once I take all the fields, and then I'm adding my new field. Okay, so existing 6 fields plus this new field, which is 7. And then I'm calling everything as a struct type, which is a new schema. In this, you will have old 6 columns plus 1 new column. And I'm creating some temporary data here, 2 rows with, having data for the new column as well. So if 1, 2, 3, 4, 5, 6, 7 columns, data for 7 columns. So now I can run this. I'm not writing yet. I'm just displaying. If I add a new column here, now you can see there is a credit score, which is integer, and the data frame will have the new column credit score here. Right? So this is the same thing. I mean, nothing new, guys. You have been doing this all this time. When you say dot with column, you are adding a new column. That's the same thing here, but a different doing it right from scratch. You are adding schema and all of that, and then adding data view. How you will have a new schema with new table with the new schema. Clear?
Yes.
Any confusion? Okay. So basically, I have my old table with 6 columns, and this is a temporary one, which is 7 columns. Okay. Now, what I want to do, for example, currently my table is set up. The data is coming in with all the loan, this blood, whatever information that I have. Now, suddenly I want to have more information for all the loans or records. I want to also see what is the credit score for that loan amount that we have given, for the loan ID that we have given, or the person who we have given that loan. So that loan ID is obviously attached to some person who has taken a loan. So I want to know the credit score for that person or for that loan ID attached to that loan ID, right? So that's a new data that is coming in. And my table structure does not have that column. Okay. In traditional world, you go and what you do, you first go and change the schema of the table. You run a DDL statement to add that column to the table, and then the new data comes in. Or if you don't do that, if the new data comes in, it will fail, right? Because it does not have a column where to write that data, correct? In the SQL statement, is that true? If the database has 6 columns and I'm passing 7 columns to write it, it will fail, right?
Yes.
Yeah.
Okay. Say, guys, say yes or no. I don't know. People, you're still here, understand? Okay. So I'm doing the same thing. I am taking this new data, okay, whatever I have created, and then trying to append to the same table, loans delta new table. I am attempting to write data with new column to the delta lake table. Okay. So I will try to write this 2 rows. So now it throws an error saying a schema mismatch is detected when writing to the delta table. Okay. It also suggests you what you want to do. You use an option to merge the schema as true. Okay. So this is one of the feature. This is where I'm alluding to, right? So when this kind of use case, we want to have more information, new data is coming in. So how does Delta handle it? So there is a feature called merge schema, and then you can enable that using the option merge schema true. Okay. It should
But Harun, in
yeah.
this case, you're saving it as a brand new table, right? So why is there a conflict? There's no
No,
conflict.
no, not brand new table. This is the same table.
No,
This is what I have
it's
created.
the same table. It's already existing table. Understood?
Yeah, this is what I created here. Let's go back. I have dropped the old one and then
Okay, and that's why you
started it.
called it underscore new. Oh, in that case, we're good. Okay.
Here, loans delta new everywhere.
Okay. All right. Sorry.
Go here.
But if you just say, like, for example, new 2, you will not see that error at all.
Yeah,
Right?
new. If you are trying a new table, it will create new schema and put it.
Right.
See here, loans delta new. That is the table name. Okay.
Yeah. Okay.
Maybe it is a misnomer, but that's fine. So this is the table name, and for into that table, I am adding 2 more new rows. Okay, but those 2 rows have an extra column as credit score. The underlying table does not have the credit score column. Version 0. Okay. Now that's why it's saying a schema mismatch. And it also says you have a feature called merge schema. You can enable that using option on that data frame to do the merge schema as true. So this, you see the table schema, whatever the old schema that you have, not the existing schema for the table, and the whatever data schema that you are trying to put in. Okay, there's 6 timestamp. Then there is a credit score new that you're trying to add to the table. Clear?
So in this case, you said the nullable equals true, right? But if
Yeah.
you say nullable is not equals to true, then this operation can never happen, right?
No, see, nullable is only applies to the data itself. Here it's failing at the schema level. It's not going at the data level yet. It doesn't even find the column first.
Okay.
Forget about whether it is a null value or it has a value or not.
Okay.
That is at the field level. First, it has to find the field, then it will go and do the check, right? So that's at the next level. Now, the top level itself, it's failing because it does not see the schema. Okay. We don't know what schema match is there. what is the existing schema and the new schema, there is a mismatch. It doesn't even find the credit score column, so it cannot go and write there, whether it is null or not null, kind of thing. So true, even if you say that true means that it can be null. Okay. False means it cannot be null. We have still made it true. So even if it is null, it should go through. But the column itself is not there. So at the schema level only, it's failing. It first does a schema match, kind of check, right? Preconditions, it has to first check. Validations, if it passes, then it will attempt to do the transactions. Okay. So now it has failed. Now we know why it has failed. We say its schema is not so matching, then it suggests you can use the feature called merge schema, which is, we call it as schema evolution. Okay. Schema evolution is basically it will handle if there are any changes to the schema. If you use the feature merge schema, the schema evolution feature will automatically handle your changes in the schema. How does it handle? It has a merge schema true mode append. Same thing you are trying to write again, but this time you are also adding an option called merge schema true. So it will automatically create and add the data to the loans delta table.
Yeah, the table should be loans data delta underscore.
So, yeah, I have to do that for all. Okay, so loans delta new 1123. Today we added these two new records to the loans delta new. Now,
can you remove the loans, the where condition, and see the previous records also?
yes. Let's see here.
Yeah.
For the old records, the data is still null.
Okay. So my previous question was coming to the place where the grade score cannot be null. In that case, how do you pre-populate existing records
Then it will
with
fail.
some default value? No, but we can put some default value, right? Where it would somehow backfill with the default value.
That is a
much of an
transaction that you need to do. Update transaction.
Oh,
It's
first
not
you
a
have to update,
DDL, right?
then do this one.
Yeah. So it's not a DDL that we run here. So when you run, you created the schema and then you run an update statement. Okay. Yeah. Now, so that's fine. So now we have created this, right? Now let's go back and see our original thing, what happened on the file system, right? So JSON, the transaction log. When we did this transaction, when we added new files or new data, and we added the schema, what happened here, right? So let's go here. It will have the same. So now we have two files, Parquet files here. Okay. But if we go into the Delta log, this is where you will see 0 JSON and 01 JSON. So this is now created version 1. So that is our latest version. So if you go here and check the history, so the latest version is version 1 now. So version 0 is what we created. This is, you can also see what is the operation, create or replace table. Then version 1 is a write operation. Mode is append. This is the first one when we created, and this is the second latest version, version 1. Okay. So if you go to version 1, now you can go and read what happened in version 1 here. Oh, new delta new delta log. Let's do this one.json. Okay, so this is what happened in version 1. Data changes true. Number of records, see how many records we have added? 2 records. So it stores that 2 records in the status, in the statistics, sorry, number of records that were added to. And then again, it's the same thing. So what is the loan amount, funded amount, minimum, maximum? So this is for the entire data set, not just for the 2 records. Okay. Minimum funded amount 10,000, maximum is 20,000.
Harun, it is recalculating this, or it's recalculating this minimum and maximum amounts and all that, right? That's because we mentioned that somewhere. I know you mentioned it previously, but I thought it's one of a statement. But is it?
No, every time you do a transaction, yes, it has to recalculate, right? The statistics.
Yeah, but the transaction was done, let's say, in the past. So why should it keep on, moving forward?
The new
that
transaction for one. So when you added 2 records,
right?
This is when it has written this JSON file.
Right, but those numbers were calculated even before we modified the schema.
Yeah, that is for version 0.
Right, and then when you modify the schema and then move forward and all that, why should it keep on carrying?
So let's say we added 2 more new records, right?
Yeah.
In that record, what if the funded amount was 5,000? So what is the minimum value now?
Right, then you're saying that it will again recompute that and put it there.
Yes, exactly.
But what if I don't want it? Like say, because that's an information that I requested way in the past, and I'm done with that
not
information.
Requesting any information here. It is everything. It is system. It is keeping it for its own benefit, not for you. It is maintaining that for its own benefit, because these are all system files. You will not use these files. The system will use these files when you do some queries. Okay. If you want to say, hey, select minimum funded amount now. In that case, it will go and do check in the transaction log. Hey, can I take it from here? Minimum value is asking. Yes, minimum value here. So it will pick up.
What's the distinction? What I wanted to ask here is that a cached value or is that at a computed value? Because let's say let's talk from an Oracle data standpoint, right? In Oracle or any other database systems, right? You can have a column that is a computed column, right? So anytime you look at it, it computes on the fly. Versus a cached value. So which means it's not computed, just snapshot, it's there, right? In this case, it appears as if this is a cached value. Also a computed, because like you said, what if when we add new records, you do have some information for the paid amount, and therefore it has to recompute it.
Yes.
Right? Let's say we want to achieve the same thing in Oracle. What we do is that we say, okay, here's a computed value, keep on computing it. But in this case, I don't want that computed value. Like say 10 days ago, I'm interested in that information. I queried the database, in this case, Spark and all everything, and I'm done with it. I'm not interested in that anymore in future. So why should it keep on recomputing it?
So it is a cached value recomputed whenever there is a change to the data.
Agreed, but I'm not interested in that anymore, because the reason why I'm saying is like this, because so let's say you have an operational system, and then there are like 10 users, and they keep on querying the system left and right, left and right, left and right, right, and the data grows bigger and bigger and bigger, and now you have some schema relations and all that. I'm done with all those things. I don't want those historical baggage to keep on moving forward.
This is not historical. So that's what I'm saying, right? Now, see, funded amount is 10,000, okay? And a loan maximum amount is 20,000. So tomorrow it has changed to 40,000.
Right.
Now I want somebody, users are, you have 5,000, 10,000 users who are accessing that database and calculating, give me maximum value of funded amount.
Right. In that
Every
case,
time you run the query, you are
yeah.
going to recompute it.
Right. So that is lazy valuation, right? On demand, lazily, it can recompute again.
Yeah. So if you have 10,000 queries, it has to do 10,000 times. Instead, it is calculating on write, so it can minimize the read time. It's internally right. So when you're writing it, let's say it compares with what is the current maximum, and when it is writing it, hey, this one is new. So I'm just taking an example. I don't know how it calculates the algorithm, but let's say it's easier, right? So I'm just computing two numbers, and then if this is greater, I'm just replacing it. That's the bubble sort algorithm. When keep computing, when you compute a maximum number, you just compare with the existing one. Whichever is maximum, you just replace it. So that is easier when I'm writing, because I have to have only one value to compare, versus if 5,000 users are executing, for example, the same give me maximum of funded amount. So it has to calculate for each user separately 5,000 times, and it has to go through the entire data to calculate that, right? So instead, when I'm calculating it or just comparing the existing value, one number, to see whether the incoming number is greater or less and replace here, that will help me. One, if somebody is giving you the exact same query to calculate maximum. And two, let's say I want to get give me the amount between 5,000 to 2,000, 5,000 to 10,000. Okay. So in that case also, it can know which files have those values. So all of that metadata is used to filter out, so that it doesn't have to read all the files to give you the data. Okay. So basically it's update statistics on write instead of calculating every time. But again, it is only the system that it uses.
So let me give you an example in this case, another use case, right? If you
Yeah.
scroll that one a little bit up.
Mhm.
Okay. Scroll a little bit down. Yeah, stop there. Okay. So in this case, you have an address state and you have funded amount, right?
Mhm.
In this case, it is California, right? If you scroll a little bit down, there's also New York, right? Now, if my use case says, all right, I need the funded amount only for the state of California, okay? And also I have another use case that says, funded amount across all the states, okay? So that two different columns, correct?
Mhm.
But then my use case two is a one-off use case. I mean, I want to, issue that information, get that information, read that information. And I know for the rest of the life of this system, I'm never going to use that. But from what I'm hearing is that Parquet and Delta Lake will keep on recomputing that, even though if I don't want it.
Yes.
Right. And I'm thinking in a sense that it's unnecessary computation that we are performing. Because see, what I'm trying to say is that you have an information that needs to be recomputed at every transaction, say every changes. That's okay. And in this case, it's doing, that's fine. But you also have some use cases where you want one-off computation. You never want it for the rest of your life. But even then why is the system still continuing that?
Because you don't know what kind of use cases you would come up with, right? You are not
No, but that's what
defining
I'm saying, right? There could
when
be
you're creating the, so this is a framework, right? So the framework is created, it applies to all the tables and all the file system, how it manages. Its entire framework is built on those rules. Now, if
agreed. But see, if it's
basically
built
you're
into
saying that there should
that,
be an option not to compute this, right?
right, because I've seen systems where they become slower and slower as time passes by. And what used to take like 10 minutes, after like 6 months, takes like 30 minutes because now the system is busy computing all sorts of things that we don't require.
Yeah.
I'm saying
I think
something.
all of those things are already handled basically, because when you are actually writing into the database itself, there is a lot of processing that is happening, right? So this is one of additional processing versus doing the whole processing kind of a thing. That's what I was saying. The incoming one number is only compared with one number. That's it. Not this, that one number is compared with existing million records, because you already have the minimum of all the million records. The new record is you are inserting, it has to do only one comparison. It need not go and compare with all the million records to find out what is the new minimum thing. But anyways, so I think, yeah, I understand where you're coming from, that you should have a option to switch on off whether I want to calculate statistics or not.
Correct. Yeah.
I get
Right.
you. Maybe we'll check if that is available. I'm not aware of it, but sure. In the interest of time, let's say if that is not available or shortcoming, we'll look at it. But this is the concept, right? Basically, these are all independent. So this 10,000 is not for CA. At least, I mean, I would just want to clarify that. This 10,000 is overall. It doesn't matter which state, whatever it is. Paid amount minimum in the entire data set, entire table. This is a string, so it doesn't have much value because you don't compare strings based on minimum and maximum value. So, but it still has done. So, and this 20,000 and this 649 is basically for the entire data set, million records or billion records, whatever you have. It's calculated minimum and maximum here, just for the sake of filtering purpose. Okay, let's move forward. I got your question. So I think you got what it is, right?
Yeah, I got it. But like from experience, right? I know systems become slower and slower. I've seen many systems. Initially, right, you put it in production, everything runs fine. 6 months down the line, it's dead horse.
Yes. Yeah, I understand that. Okay. Yeah, so we have seen the this merge schema, and then we have got this new columns added. Now, how does it help in the time travel? So what does time travel do? So we were saying, right? So if you see here, is it the picture you can see, it's 1.json, 2.json, 3.json is all like a version, right? So what your snapshots, okay? You can query the snapshots tables by version number or timestamp. Okay, so when you want to, I want to do the query, I can do. So now, if I say describe history, we know we have two versions, right? One is 0, and the other is the when we added the new schema. Okay, mode append. So these are the two versions that I have, 0 and 1. If I just do select star from, like we did here, we are getting all the data from the latest version, that is version 1, correct?
Yes.
Right, because we didn't specify.
Yeah, so version we don't specify, it always gives you from the latest version. That is why we have a credit score, and then we have values also that we did for 2 records. Now, if I want to go back and say version 0, okay, then I can go here and say spark.sql select star from loans delta new version as of 0. So you can add this qualifier for the table and say which version you want to get. Okay, and you can also do count as version 0. Okay, so if you see here, version 0, you haven't added the new column, correct? Version 0 didn't have the credit score. So if you want to select data as of version 0, you don't get the credit score here. You only get these 6 columns. the data, and the data is 14,705 rows. Okay, remember the 705. Now, if I want to go and do the latest, if I don't give any version, oh, sorry. Everywhere. Okay, so if you see, if I just say without version, latest one, I get the credit score column also in this schema. And if you look at the data, you can say 707, 2 rows. Because in version 1, we added a column and then we added 2 new rows. So the count is 707 for the latest. But for the older version, there are only 6 columns and 705 rows. Clear? So this is how you do the time travel part. Any questions on this time travel? Now I'm doing more transactions on this. So I want to do update credit score. This is what we said. We want to update the credit score for, the loan IDs, where the loan ID is less than 10. Okay. This you will not see any information here. Once.
Again, loans.
Yeah, sorry, you're saying something?
It should be from loans delta new.
No, that's fine. I didn't execute this yet. So I was just trying to get you. Okay. You want to go back here. Now that we did more transactions, I want to refresh this and see, go back to history. And then I see a new version 2. Okay. New version 2 is done, update. Okay. It also tells you what you updated based on what. So loan ID less than 10, right? This is what the SQL you have used, predicate. So it also stores that information, operation parameters, what was done on this update. Let's go back. We want to see the JSON file, right? So what happens in the versions here when now you have updated another transaction? Yeah. So if I go here, now I will get 01 and 02 JSON, correct? Yeah. So 02 is my latest. Now, if I want to go and see what happened in 02.json, I just go and check 02.json. So here, data changes to number of records. What happened to this? 14,705. So this is add. Remove. Oh, we only said add here. Okay. 1705. This is the old one. There should be 707.
Or is it JSON 3? If you go up, is it JSON 3?
Oh, JSON 3. No, I think it's just JSON 2.
Yeah, it's 0, 1, 2, right? We had only two words, 0, 1, and 2.
0, 1, and 2. Yes. Okay. Yeah, I will check this. How to read this, but basically, yeah, you can go back and check what is the okay. So this is the actual file, and it has, see, number of files removed. Okay. So internally, when you update something, it kinds of adds and then removes some files. And then it will note here which records or which files are relevant, as I was saying, right? Which files are relevant, which files are not relevant right now for each version of the JSON. Okay. So here, number of copied rows, 14,695. Okay. So out of 705, 10 records we have updated, right? So it copied all this 14,695, which we did not update as is. And then the new rows, it has 10 rows that it has added as a new with new data. So somehow it manages removing old records and copying the data into the new file and marking the old one as the relevant and new one with the current data as the relevant. But all of that is linked to your version. So if you go to this version, it knows what files are actually relevant and what files are not. So if you go to 0.1, it knows, so the files are different because the schema is different. So it has to read the data from different files. If you go to 0.0, version 0, the schema is different. So it knows which files to read for that version, what is the schema and what is the data. So all of that data is put here. Number of copied rows, number of added files, number of updated rows is 10. See here. So 10 rows we have updated. Okay. And the path, it shows, see, remove this path, this file, okay, which is not needed. And then add this path. So these files, which is added. Okay. So which means it will, on each version, it knows which files it should not read and which files it should read for the current data. Okay, that's what it is doing here, adding all of the data into this each metadata JSON file to read. Okay, any questions on this? Did you get this? See, again, I'm just reiterating so that you don't get overwhelmed. You are not supposed to do any of this. This is only for the purpose of understanding, so that in the interviews you can ask, you can answer questions, or you can talk about, how Delta Lake supports the ACID transactions, right? So you should talk about, for each table, it creates a path for the data files. It creates a Delta log where it does transactions and creates version for each transaction or write operation that it does. And then it notes down all the statistics, all the files that are relevant based on the operation you have done, which files to choose from, which files to ignore, how many records it has added, how many records updated. So all the metadata related to that transaction that created the version is stored in this JSON file. Okay, so this is the heart of it or brain of it. So once you remove this, it doesn't know at all what to do. It falls back probably, it just goes back to the old version maybe. But again, there will be inconsistency if you have the versions. Let's not go there, but simply put, this is where, for when you say go latest or just do a select, it goes to latest, which is 02, and then it scans this file and then gets all the information that it needs to execute whatever queries or whatever you want to do on that table. Okay. Any questions? Go through this recording. I will publish the file, run this. Okay, create your own new data, a new table name, and make sure you change the table name everywhere and execute this. Okay, see it. We will continue tomorrow. So basically it's the same thing. So you kind of do some transactions, go to the history, check what is there in a version. So tomorrow maybe just we'll touch upon the time travel. We'll see we already seen the versions, but if you want to overwrite or roll back, what you can do. Just run some couple of sequels on this and see. But basically, this is the transaction or the Delta, how it manages the transaction log and supports ACID transactions and time travel. Okay. We will look at these delete, update, merge, GDPR, CCPA, basically deletes, right? These things we will review, revisit tomorrow, then we will move on to the next step. Okay.
Okay.
All right. I think we'll wrap that up here. Any questions before we wrap up?
Harun, today class is good, but I have reached out to you in the WhatsApp, I think 2 days back.
Yeah.
So
give me a call.
okay.
We will have a separate offline session.
Okay.
And then we'll clear any questions or errors that we have. Or we can use this time tomorrow. When we have some time, we can we'll check that errors. Okay.
Oh, okay, sure.
Okay, no worries. All right, guys. Thank you so much. Appreciate it. We'll get back meet tomorrow then. Okay.